Clustering in cloud computing. Clustering is a technique in cloud computing where multiple servers, often called nodes, work together to act as a single system. The primary goal of clustering is to improve performance, availability, and reliability. In a clustered environment, if one server fails, another can take over its tasks, ensuring that the service remains uninterrupted. This is especially crucial in cloud environments where uptime and scalability are vital. Key concepts of clustering in cloud computing. 1. Nodes. Nodes are the individual servers or machines within a cluster. Each node has its own CPU, memory, and storage, and they work together to process tasks. In a cloud environment, nodes can be physical or virtual machines. 2. Load balancing. Load balancing is a process where the incoming requests are distributed across multiple nodes in a cluster. This ensures that no single node is overwhelmed with too many tasks, leading to improved performance and resource utilization. Load balancers are often used to manage this distribution. 3. High availability, high availability ensures that a system remains operational even if one or more nodes fail. In a clustered environment, if one node goes down, the other nodes can take over the workload, minimizing downtime. This is critical in cloud computing, like where users expect services to be available 24/7. Number 4. Fault tolerance. Fault tolerance is the ability of a system to continue operating even in the event of a failure of some of its components. In a cloud cluster, if a node fails, other nodes can pick up the slack, ensuring that the overall system remains functional. 5. Scalability. Scalability refers to the ability of a system to grow and handle increased loads. In a cloud cluster, adding more nodes can increase the system's capacity, allowing it to handle more requests or data. This makes clustering an essential part of cloud environments where demand can fluctuate. 6. Distributed computing. Distributed computing is the process of using multiple nodes to work on different parts of a task simultaneously. In a cloud cluster, tasks can be split across nodes, allowing for faster processing and more efficient resource use. 7. Cluster management. Cluster management involves overseeing and controlling the nodes within a cluster. This includes monitoring node performance, managing resource allocation, and handling node failures. In cloud environments, cluster management tools like Kubernetes, Apache Mesos, or AWS Elastic Beanstalk are often used. 8. Replication. Replication is the process of copying data across multiple nodes in a cluster. This ensures data redundancy and availability. If one node fails, the data can still be accessed from another node. Replication is crucial for data-intensive applications in the cloud. 9. Clustered applications. Clustered applications are applications designed to run on multiple nodes in a cluster. They can take advantage of the cluster's resources, improving performance and fault tolerance. Examples include distributed databases, web servers, and big data processing frameworks like Hadoop. Real-life use cases of clustering in cloud. 1. E-commerce websites. Large e-commerce websites like Amazon or Flipkart use clustering to handle millions of users simultaneously. If one server goes down due to a hardware failure or overload, other servers in the cluster can take over, ensuring that the website remains available and responsive. 2. Big data processing. Companies like Netflix or LinkedIn use clustering to process large amounts of data. For example, they might use Hadoop clusters to analyze user behavior and improve recommendations. By distributing tasks across multiple nodes, they can process data much faster than a single machine could. Number 3. Online gaming. Online gaming platforms like Xbox Live or PlayStation Network rely on clustering to provide a smooth gaming experience for millions of players worldwide. Clustering ensures that if one server fails, the game continues to run on other servers, minimizing disruptions. 4. Financial services. Banks and financial institutions use clustering to ensure that their online services, like banking apps or trading platforms, are always available. Given the importance of uptime in the financial sector, clustering helps them avoid costly downtimes and ensures that transactions can be processed without interruptions. 5. Cloud storage solutions. Cloud storage providers like Google Drive or Dropbox use clustering to store and manage vast amounts of data. Clustering allows these providers to distribute data across multiple servers, ensuring that if one server fails, the data is still available from other servers. Example of clustering in cloud. Kubernetes is a popular cluster management tool often used in cloud environments. It allows organizations to deploy, manage, and scale applications across a cluster of servers. For example, a company might use Kubernetes to manage a web application running on a cluster of virtual machines in a cloud platform like AWS or Google Cloud. If the application experiences a spike in traffic, Kubernetes can automatically scale the number of nodes in the cluster to handle the increased load, ensuring that the application remains responsive. Conclusion. Clustering is a fundamental concept in cloud computing, enabling high availability, fault tolerance, and scalability. By distributing tasks across multiple nodes, clustering ensures that cloud services can handle large volumes of data and traffic while minimizing downtime. Whether it's an e-commerce platform, a big data application, or a cloud storage solution, clustering plays a crucial role in ensuring that these services are reliable, efficient, and always available to users.